Hello friends, welcome you all in the video Theory of Computation or Theory of Automata. In this video we are going to discuss the basic terminologies of Theory of Computation. Means what is automata, what is the meaning of Theory of Computation, what are computations, and what are the different terminologies they are necessary for understanding the automata theory or theory of computation. So basically, when we see the definition or terminologies introduction with respect to the theory of automata, so it is basically theory of automata is a theoretical branch of computer science and mathematics. So it is one theoretical branch. It has practical applications also, and it is basically theoretical concepts. It deals and can be used in computer science in many applications, and it has the applications in mathematics also. Basically, theory of computation or automata theory is nothing but it is the study of abstract machines. So first of all, you must know what is the meaning of abstract machine or what is the meaning of abstract. So if you see in the dictionary, the meaning of abstract means it is just the abstraction means hiding the implementation detail, presenting the functionality. Means user will only know how this particular thing will work and how it is going to be implemented. That is totally hidden from the user. So that particular word, it is mean abstraction. So that word abstract means hiding the implementation detail, presenting the user the functionality. Means user will know to how to use it, but how that particular function or how that particular functionality is implemented, that will be not visible to the user. So that particular things are called abstract things or abstraction. So it is basically automata is the study of abstract machines. Means they are implemented, the machines will be have functionality, but their implementation will not be known to the user. User will know to use the functions, but how to use that particular functions is not known, or it is hidden from the user. So now the abstract machines is a model of computer systems. So basically it is a model. It is basically a proposed model, or it is just a model of a computer system. Computer systems may be hardware or software, considered as either as hardware or software. It can come, the model may be in the form of a hardware or it may be in the form of a software. Now why it is constructed? It is constructed to allow a detailed and precise analysis of how the computer system works. Basically that models are used for study purpose, means analysis purpose, how this particular proposed system, how this particular system will work, like that. Such a model is usually consist of, as it is of in the form of a hardware or software. So basically it will consist of some input, it will produce some output, and operations that can be performed on the operation set or data. So can be thought as a processor. So it is basically performing some operations by taking some input, and it is producing some output. So it can be thought as a processor. So that model, usually whatever the model the automata is going to be work on that particular thing, maybe it is a theoretical model which will take some input and it will produce some output by performing certain operations. So it will perform certain operations based on the certain input and output. So we are going to construct the model, theoretical model of that particular thing, how that particular system will work. So that's why the word abstract is used with this type of models, or with this type of whatever systems are there, because they are just they are just shown the operations, how it will be performed, it will be totally hidden for that particular user, and the computation problem that can be solved. And basically, as we have seen in the first line itself, that automata theory can also deal, and it is also a branch of mathematics that can be used for solving some computation problems. So basically, automata is a theoretical branch which can be used in computer science for constructing hardware or software models, and it can be used in mathematics for solving some computation problem. So it has both the application. It can be used in mathematics also, and it can be used in computer science for solving the problems and for obtaining the problem solutions for certain set of problems. So now, the abstract machine, whatever we are going to propose, or whatever model of that abstract machine, it is called as an automata. So automata is nothing but it is an abstract machine. It can process certain input, will produce certain output, and it can model functionality of either hardware or software, how that particular thing will work on that particular set of input. So that is the basic thing automata will do. Now, an automata or automaton with a finite number of state is called finite automata. So this automata, as it is a mathematical model or computational model, is having certain states. So these automata consist of states and transition. The states represented by is represented by the circles, and transitions are represented by arrows. Now, so automata is the kind of machine which takes some string as input. This input goes through the finite number of states and may enter the final state. So automata is a kind of machine which takes some string as input, and this input goes through the finite number of states and may enter in the final state. Means it has certain set of inputs, so that states may be considered as input state, final state, and there may be intermediary states are also there. Now, what are the basic terminologies used in this automata are like symbols, then alphabets, strings, and language. So these are some basic terminologies which are used in this particular functioning of the automata that we are going to study here. So what are the symbols that can be used in study of automata theory? So symbols are either entity or individual objects which can be either letter, alphabets, or any picture. Like for example, these are symbols, alphabets or digits, or maybe special symbols, so like that, or maybe some certain objects like that. So that will be considered as a symbols. So symbols will come in this particular category. Alphabets, as we know alphabets already. So alphabets are finite set of symbols. It is denoted by sigma. Sigma is equal to collection of alphabets like A, B, C, D, or 0, 1, or collection of like this, or certain special symbols. So that can be considered as an alphabet. So symbols, alphabets, and then the collection of alphabets and special symbols. Now it also has the terminology called string. So what is a string? It is a finite collection of symbols from the alphabet. The string is denoted by W. The string is denoted by W. So a string is the finite collection of symbols from the alphabet. The string is denoted by W. For example, if alphabet sigma is equal to A comma B is various strings, then that can be generated from the sigma are combination of A, B like this. So all possible combination of these input symbols like A and B, they are the collection. So that can be called as an input string. So all the combination of these input symbol A and B will be considered as the string. So we have seen symbols, alphabets, and strings. Then a string with zero occurrence of symbol is known as empty string. So now string has many terminologies like that. So what is empty string? So the string with zero occurrence of symbols, input symbols, zero occurrence of input symbol, it is known as empty string, and it is denoted by epsilon. Epsilon. It is denoted by epsilon. So empty string is generally denoted by epsilon. So that empty string is nothing but zero occurrence of input symbols like that. Now next terminology is the number of symbols in a string is W, is called length of a string, and it is denoted by mod of W. So W mod. So the number of symbols in a string is called W. The length of the string is denoted by W or mod of W. So for example, if we take W equal to 010, so the number of strings is equal to 3. So number of characters or number of alphabets or number of input characters are 3 in this case. So mod of W, that is length of the input string, is equal to 3. So in this case, W mod of W, it will give the length is equal to 3. So that is string. Next terminology, now coming to the language. So we have defined like terminologies like symbols, then alphabets, string, and length of string, and we have seen how to find out the length of the string. Now we are going to find out what is the meaning of the language. Now a language is basically collection of appropriate string. So language is basically a collection of strings, and it is denoted, a language which is formed over sigma can be a finite or infinite. So there might be a finite language, or it can be a language can be infinite. So for example, suppose L1, we are having language 1, that is set of strings of length 2. So it may have the combination of all the strings which are having the length of input characters, or the length will be 2, means it will have 2 characters like this. Now second language L2, like it is given like this, set of all strings start with A. So example like this, A, all the string combination, possible combination which are going to be start with the A. So in this case, so it may have the infinite language like this. So in this way, these combinations and all that things, they depend upon what is the language, or how we are going to define the language in that particular set. So if the language is given in this way, set of strings of length 2, so it will have all the combinations of the input string with the length 2. Set of all strings which starts with A, so it will have all the strings which are going to be start with A. So these are the some terminologies which are going to be associated with the automata theory. So first of all, we must know what is the meaning of automata. So automata is nothing but it is a model of abstract machine which can be used in computer science and mathematics. In computer science, it is going to be used for constructing the model of the different systems that can be either hardware or software, and in mathematics it can be used to solve computational problems. Basically they are used for solving the computational problem. And automata has different states like input state, output state or final state, and intermediary states. Basic terminology is associated with the automata is symbols. Symbols may be alphabet, digits, or any special characters. Alphabets may be combination of alphabet like this, A and B, or all this, like this will be all alphabets, collection of all these things. So it is denoted by the symbol sigma. Sigma is the alphabets. Now string, it is a collection of symbols from the alphabets, the string is denoted by W. So string may be all collection of symbols from alphabet. So the string is denoted by W. Example of the string is sigma is equal to a comma b is the various strings that can be generated from sigma are the AB, AA, BBA, like that. So these are the various strings that can be generated. So now we are going to define null string. So a string with zero occurrence of symbol is known as empty string and it is denoted by epsilon. The number of strings, the number of symbols in a string is called length of the string and it is denoted by mod of W. So mod of W will give the length of the string. So like this particular string we have the length 3. The language we have defined, like a language is a collection of appropriate string. A language which is formed over sigma can be finite or infinite. Example, L1 set of strings of length 2, L2 set of all strings start with A. So like this, these are different strings and set. So this is regarding the basic terminologies which are used in study of automata. In the next video we will discuss some more terminologies related to automata.